those examples are good ones to come back to when you're having trouble evaluating logs. Come back and look at these and really think out what it's saying and try saying them. Okay, here's a challenger. What power do you put on 7 to get 1? I'm looking for an exponent. If I put it on 7, I'll get 1. Well, 7 to the power of 1 is too big. That'll be 7. It's got to be less than 1. And you'll find that any fraction in between is not going to get you there. This is a great test question. Yeah, you can 5-star this one right now. We're going to put something on this test that says log base whatever equal of 1. And the answer is 0. 7 to the power of 0 equals 1. You're looking for the exponent you put on 7 to get 1, and that exponent is 0. Ooh, that's in the way. What power do you put on 1/2 to get 1 over 32? Well, 1/2 squared is 1 over 4. 1/2 cubed is 1 over 8. 1/2 to the power of 4 is 1 over 16. And 1/2 to the power of 5 is 1 over 32. Imagine putting power 5 on 1, you get 1. Power 5 on 2, you get 32. There it is. Oh, question for discussion. How do we sketch the graph of log 3x? And I think it's very important to understand that we're talking about the inverse. Now there's multiple answers to this, and we'll talk about a lot of this in the chapter, and the method you use for tonight's homework might be different than the method you use by the end of the chapter. I'd argue that I wouldn't, when I see log 3x at this point, I wouldn't graph this. I would graph y equals 3 to the x. And once you graph 3 to the x, then you can just do the inverse of all the points, just flip all the points. You should be able to graph 3 to the x fairly easily, but it's good to use those reference points that we talked about on one of the opening screens. So looking all the way back, hey, let's see if I can pull this off on the screen. I don't know how good this is going to come off. Okay, go to slide 2. There it is. So there's y equals 3 to the x. If you want to graph log 3 of x, you just take each of these points and flip the x and y values. So 0, 1 would become 1, 0. 1, 3 would become 3, 1. 2, 8 would become 8, 2, and so on. And then you get your logarithmic function that will be in kind of here with those points. Okay? So you can just graph the corresponding function, the exponential version of it. So for log 3 of x, graph 3 to the x, and then exchange all the x and y values. And that's the end of the show.